Okay, here's a quick little scribble class that gives you a couple of questions dealing with double angle or half angle identities. In the textbook, they get fairly involved with that and use them to manipulate and determine new identities and other things like that. I want to focus just on a practical way. I don't know how practical, but practical way of using a double or half angle identity to determine the exact value of certain expressions. So this particular question asks for determining sine 2 theta, tan 2 theta, cos 2 theta, and the quadrant in which the angle 2 theta lies. The information that's given me is that the tangent of theta, not 2 theta, but the tangent of theta is negative 3/4, and that the angle just theta is in the second quadrant. So second quadrant right there. Okay, now given that information, well, maybe I'll take a look at this sine 2 theta. If I look at my identity sheet, they do give me an identity here that says that sine 2 theta is equal to the 2 times the sine of theta times the cos of theta. So if I say start with A, so I want to figure out what the sine of 2 theta is. From that identity, it's 2 times the sine of theta times the cos of theta. Okay, so, but in my question they give me the tangent of theta, so I don't really have any of that stuff. But I know from doing past questions that if I know the tangent ratio of an angle, I can determine the sine and the cos ratio just by using Pythagoras. So if I take that and say, all right, tan theta is 3/4. They also say it's in quadrant 2, so over here, x would be negative and y would be positive, right? So if tangent is y over x, then y is positive, so the 3 would be positive, and the 4, the x is negative here, so this x has to be negative. Just to identify which of those numbers the negative should go with. Not that it matters a whole lot, but maybe in a question it would. Okay, so I need to figure out r. X squared plus y squared is r squared. 3 squared is 9, plus negative 4 squared would be 16, is r squared, so r comes out to the square root of 25, which is 5. So if I know what r is, then I can determine what sine is. So sine theta would be y over r, and y from up here is a positive 3, and r is a positive 5. So their sine theta is 3/5, and that's in my formula right there. So I can plug in a 3/5 right there, and the 2 is still out the front. Now I just have to figure out the cos theta. Just one thing before I go too far with this one, though, is that no, I think I'm good. Sine theta is positive. All right, so cos theta would be x over r, and x from up here is negative 4 over r, I just found out, was 5. So cos theta is negative 4/5. So I put in, instead of cos theta, it's negative 4/5. Multiplying all that stuff together, I get 2, this is like 2/1, right? 2 times 3 is 6, times negative 4 would be negative 24, over 1 times 5 is 25. So the sine of 2 theta, 2 times that original angle, is negative 24/5. Notice that sine is negative. That means these two quadrants, it could be in one of those two. I don't know which one, but it could be in one of those two. Okay, that's A. Now to determine B, I would do the same thing. Cos 2 theta. Okay, now let's go look. Is there an identity for that one? Oh, here's one right here. Cos squared minus sine squared. All right, so cos squared theta minus sine squared theta. Now in class we've talked about this one, that cos squared theta really means cos theta times cos theta, and sine squared the same thing, sine theta times sine theta. But we just figured those out right over here. So cos theta is negative 4/5, so negative 4/5. This cos theta will be another negative 4/5. Sine theta is right there, so I have 3/5 times 3/5. So altogether, negative 4 times negative 4 would be 16 over 5 minus 16 over 25 minus 9 over 25. So that would be 7 over 25. And also notice that it's positive, because a negative times negative is positive. This would be 16 25ths minus 9 25ths. I get 7 25ths. It's positive. So cos of 2 theta is a positive 7 over 25. Now, if cos is positive, that means it must be in this quadrant or that quadrant. Now you can start taking a look here, because this one and this one, if I piece those two together, the only check mark that is common in them is this check mark. And so it would mean that the angle 2 theta must lie in that fourth quadrant there. So I guess that answers question D. Question C is tan 2 theta, same game. Tan 2 theta is equal to this, so I plug in whatever tan theta is from up top there, negative 3/4. I plug it in right there, I plug it in right here. It's tan squared, so there'll be 2 of them, and I manipulate that till I come up with some kind of a fraction. Okay, so that's one type of question that you might see in the section 7.2. The other type of question is a half angle identity. And here, again, it's the same kind of thing as we've done before, is we're using one side. If we have one side, I can replace it with the stuff on the other side. So if I'm wanting to find the exact ratio of tan of 75 degrees, I want to figure out what the value of that ratio is. Exact value. I could use sum and difference identities, like 35 is 30 plus 45, but I could also use a half angle identity. So tan of 75 is the same thing as tan of whatever divided by 2 is equal to 75. Is that 150? 150 divided 2, yeah, that's 75. So this is the same thing as this. And now I have this right down there. So all I have to do is replace whatever's here with the stuff over here on this side. Okay? So I go tan 150 over 2. So tan 150 over 2 is the same thing as plus or minus square root. This looks ugly. Oh, now these ones down here look a little nicer. Maybe I should have used those. Well, we'll go with this one. See what happens. 1 minus the cos of 150 over 1 plus the cos of 150. Okay, keeping going. Cos of 150. Okay, 150 is, start here, 90, 150. It's almost over there. So the reference angle here is 30 degrees. So cos of 150 is the same thing as a cos of 30. And cos of 30 is root 3 over 2. So this would be plus or minus square root of 1 minus, oh no, it's cos over in this quadrant, C-A-S-T, is negative. So this would be 1 minus a negative root 3 over 2. Okay, all over 1 plus root 3 over 2. And then the rest of the game is just trying to manipulate, rework that. So plus or minus square root of, on the top it'd be 1 plus root 3 over 2. On the bottom it'd be 1 plus root 3 over 2. Well, that looks a little odd, because those are identical. If those are identical, then I don't know if that's going to work. Well, whatever. If those are identical, I can cancel them. So that would be 1. So it would be plus or minus the square root of 1, which is plus or minus 1. Interesting. I guess I could go and play with these two over here and just see what happens with those as well. That's the idea, though. I think I must have done something wrong in there, because it shouldn't. Oh, this is what I did wrong right there. This cos of 150 right there should have been a negative root 3 over 2. So this one right here should be a negative root 3 over 2. That's what I did wrong. It's always good to find little mistakes like that when you're recording a video. Okay, so then in simplifying, on the top there, if I get a common denominator, it would be 2. So I'd have 2 plus root 3 over 2. Whoops. And then on the bottom, same thing, it'd be 2 minus root 3 over 2. Since they both have denominators of 2, this is dividing, so if I wanted to, I could rewrite it like this, plus or minus the square root of 2 plus root 3 over 2 divided by 2 minus root 3 over 2. And then divide, invert, and multiply. So plus or minus, you see sort of the fun stuff that happens now. This would be times 2 over 2 minus root 3. The 2's cancel, so I'd be left with plus or minus the square root of 2 plus root 3 over 2 minus root 3. And you could probably keep going with that, like having a radical on the bottom of a fraction you shouldn't do, so maybe you should multiply top and bottom by the same thing, and then simplify. You might as well do that. Plus or minus, so the top is 2 plus root 3, the bottom's 2 minus root 3. So I'm going to multiply top and bottom by the conjugate of this, which is 2 plus root 3. 2 plus root 3. Oh, so plus or minus. On the top I'd get 4 plus 2 root 3 plus another 2 root 3, so that's plus 4 root 3. And then root 3 times root 3 is the root of 9, which is 3. Over, that'd be 4, plus root 3 minus 2 root 3, that cancels. Minus root 3 times plus root 3 would be minus root 9, or a minus 3. Okay, I'm still going. 4 plus 3 would be 7. So on the top I have 7 plus 4 root 3, and on the bottom I have 1. Or plus or minus the square root of 7 plus 4 root 3. It's sort of funny to have a radical inside another radical. There's probably a way that I could get rid of that, but that's probably where they would end that particular question. Quite a bit of manipulation you can see going through. Key point though is that you can, if you can manipulate the question to look like an identity like this one, then whatever you see on this side I can replace with the stuff on that side. Okay, hopefully that helps.